Hello everyone. Today we're looking at two more patterns to show triangles are congruent. We're looking at the angle-side-angle pattern and the angle-angle-side pattern. So what we've seen so far is the side-side-side pattern and the side-angle-side pattern. Those are the two patterns we've looked at so far to show that triangles are congruent. And you'll recognize that what we're doing next is going to be the angle-side angle pattern. And so that's noticeably different here because now all of a sudden we're going to have two angles and one side, and the side is going to be between the two angles. And then the last pattern for today is the angle-angle-side pattern, which again will have two angles, but the side is not between the two angles. So we're going to see those patterns here in these boxes. So first, the angle-side-angle pattern. This happens to be a postulate. So if two angles and the included side, remember included means that it is between. We're saying this side is between the two marked angles. So if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So here are the two sets of angles. Here's the first pair of congruent angles. Here's the second pair of congruent angles. So notice that the side, the included side, has to be between the two marked angles. So segment AB is not between, it's only touching one of the angles. Segment BC is not between, it is only touching one of the angles. But segment AC is between the two marked angles because it is touching, the segment is touching the markings on both of those angles. So again, as a note, the included side is between the two marked angles. Alright, and so to fill in the blanks here, if we know angle A is congruent with angle D, and if we know segment AC is congruent with segment DF, and if we know angle C is congruent with angle F, then we know that triangles are congruent. Triangle ABC congruent with triangle DEF by the angle-side-angle pattern. The second pattern we're looking at here then is the angle-angle-side pattern. This happens to be a theorem. It's a little more complicated to prove, but here's the pattern. If two angles and a non-included side, so now we're talking about a side that is not between the two marked angles, so a non-included side relative to the two marked angles of one triangle are congruent, two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So again, you can see that we have a pair of angles at A and D, a second pair of angles at D and F. So notice that, unlike the previous diagram, the included side was marked, but now it's not. We are looking at one of the two non-included sides. There are two non-included sides, and we're just looking at one of them. We're using the right one as the example here. So notice in this case that this is a non-included side. So the non-included side is not between the two marked angles. Alright, so there's your difference between the included and non-included sides. Alright, filling in the rest of these blanks, here angle A, again, congruent with angle D, angle C with angle F, segment BC with segment EF. So the triangles can be said to be congruent. So again, there's two parts to our notes today. The first part is to practice identifying the markings in the diagrams to see if we have one pattern or another pattern, and then the second part will be some two-column proofs. Alright, so let's take a look at this bottom section here. Can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem. So when it says state the postulate or theorem, that means what pattern do we have? So here's, in part A, we have one pair of congruent angles. Here's a second pair of congruent angles. And we do have vertical angles. We know vertical angles are always congruent. So you are allowed to mark those. But this is none of the patterns we've studied. Right? The patterns we've looked at so far include these four. And what we have here in this marking is a angle, angle, angle pattern. There's no such pattern as angle, angle, angle. I showed the other day, the previous section notes, that if you use angle, 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 you cannot always get the same two triangles. You'll get different triangles. So that's not a pattern to prove triangles are congruent. There is no pattern. So can the triangles be proven congruent? No, not in this case. Here's part B. We have a single pair of angles. Here's a second pair of angles. And here's the shared side. So with the reflexive property, you're allowed to add that marking there. So what pattern do we have? It's, again, helpful to cover up one of the triangles and just focus on the markings that we have in one of the triangles and just ask, what do I have? Okay, I have two angles that are marked. So the question is the side marked between the two angles or not between the two angles? And that's what we have here. It's not between the two angles. So when I put down my letters of A's and S's, we have to put the S not between the two A's because we have the side as a non-included side. So again, here's a technique you can use. You can mark your diagram. This is an angle. This is an angle. This is a side. And so you have to sort of start here, work your way around, or even vice versa. So this would be the angle, angle, side pattern, or if you went backwards, it would be the side, angle, angle pattern, and that would be okay too if you wrote down side, angle, angle. And so the answer is yes, these triangles can be proven because we have the exact same pattern on both sides. Again, we have the angle, angle, side. Or if you go the other way around, side, angle, angle. Here in part C, we have, again, vertical angles, so we're allowed to add markings with vertical angles as they are congruent. And then take a look at just one of those triangles and notice that we have an angle, a side, and an angle. Right? So it's an angle, side, angle pattern. The side that's marked is between the two angles, so we're going to put the letter S between the two A's in writing down this pattern. So once again, yes, by angle, side, angle. That's the pattern. Alright, try part D. Look at this one. What do you think? Can we show the triangles are congruent? And what pattern would you use? Did you see the vertical angles? Take a look at one of those triangles. Here's an angle. Here's a side. Here's an angle. You see the same pattern showing up on both of those triangles. So this is an angle, side, angle pattern. So again, yes, angle, side, angle is what we use. Take a look at part E. What do you think about this one? This is, no, we cannot show the triangles are congruent. Notice that we do have three parts, but it's none of the pattern that we've seen up there. We have two sides that are marked. So the only pattern that we have with two sides that are marked is this pattern, the side, angle, side. So the question is the angle between the two marked sides? So here's the two marked sides. And so we want to know, is that the angle that we see marked right there? No, that's the included angle. They marked a non-included angle. So this is not a side, angle, side pattern. It's a side, side angle, and this will never create two congruent triangles. So we cannot use any combination of three parts. It's only very specific combinations of parts, and we're learning to see what those patterns are. This is not a pattern. That angle, angle, angle pattern that doesn't exist. You can never show triangles are congruent. And this is not a pattern either. So those two don't work for us. The others so far do. What do you think about the diagram in part F? I see an angle. I see another angle. Alright, so I've got two angles so far. So with my patterns of two angles, either I have to have a side that is between the two angles or a side that is not between the two angles. Do I see that showing up here? And so looking at one of those triangles, here's the two angles. This bottom side is the side between the two angles, but that's not marked. So the side is not between the two A's, it is beyond it. So this is our angle, angle side pattern. We're going to continue practicing identifying the patterns in these next few figures. And let's see if we can now take a look at example 2. Alright, so here in example 2, we've got these two triangles, triangle STW, STW, and triangle VWT, VWT. Can these two triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem you use. In other words, what pattern do you see? Now notice there are lots of triangles, but we're just identifying specifically which two triangles. In other words, we're not looking at this triangle. We're not using triangle TWU. No, we're using these two triangles. And it can be really helpful to actually take these two triangles and separate them, pull them apart, and redraw them. Because with them overlapped, it's going to be really difficult to see with all these extra angles and points kind of in the way. So I'm going to take this triangle, triangle STW, and just draw a little version of that over here. So for example, angle S has the 60 degrees, angle T has the right angle, and angle W is over here. Then I'm going to take this right-handed triangle. This is triangle VWT, so angle V is 60 degrees. Angle W is the right angle, and then angle T is on the left-hand side. So that might be a little easier. That's a technique you can have when you have figures, kind of like these two, where the figures are overlapping each other. You can redraw them by pulling them apart. So, can we show that triangles are congruent? Well, with the pair of angles that are the 60-degree angles, those are obviously congruent. So I'm marking them both on the original diagram as well as on my sketch, so I can look at both of these to help me see what's what. We also have the pair of right angles, so again, those are obviously congruent. So far, I have two angles marked. We don't have anything about a third angle, and that wouldn't help us anyway. What about sides? Do we have any sides that are marked? No, we don't have any sides that are marked. But is there anything we can determine from the sides? Notice that when you are looking at the two triangles, both of them have a segment called segment TW. Right? They happen to share this common side. Notice that is your reflexive property. We're used to seeing the shared side in a figure like here in part B, where the two triangles sort of come together and share a common side where the side is more in the middle. Here the common side is not in the middle, but it's on the bottom because the triangles are overlapping each other. So because of that common side, then that's your reflexive property. Again, notice that the name is the same. Segment TW is congruent with segment TW. If it has the same name, that's your reflexive property. So I have an angle, and I have a side that's marked, and the side is not between the two angles. So that means this pattern is angle, angle, side. So the answer is yes, we can, and this is how. Here in part B, these triangles are not overlapping each other, so I don't have to redraw them, I don't have to pull them apart. Notice again we do have that shared side right there in the middle. Here's a pair of angles. Here's a pair of right angles. So again, it can help to just cover up one of the triangles and just look to see what we have. We have two angles that are marked with a side in the middle. This is our angle, side, angle pattern. Again, the S is between the two A's because the side that is marked is between the two marked angles. Example 3, really more of the same. Can we show these two triangles are congruent? Is it possible to prove that the two triangles are congruent? If so, state the postulate or theorem you use. Alright, so we want to show these two triangles are congruent. What do we have? Well, I have a pair of angles. That's good. I have a shared side. That's a reflexive property. Let's mark that. Can I use this side? Well, no. You can't use parallel sides. You only want congruent parts, and these are not congruent. They're just marked as parallel. So remember, anytime you have parallel lines, that's a dead giveaway. We want you to find an angle pair, because if parallel lines are cut by a transversal, then, in this case, alternate interior angles are congruent. Right? The angles must touch the parallel lines. The parallel lines create the angle pair that we need. And so now, we look at a triangle, we have two angles that are marked. The side that is marked is between the two angles, so this is an angle, side, angle pattern. So yes, we can show those two triangles are congruent. Here we have two triangles again that are overlapping each other, so if it helps we can redraw them by pulling those two triangles apart. So here's vertex T, here's vertex Z, and vertex X. And then this triangle on the right hand side is vertex V at the top, vertex W at the right, and then vertex Y on the left. Now let's think about the markings that we see here. Notice on the original diagram here in triangle TVX, we do have a little arc symbol right here at this angle. So this is angle X that we see marked, and similarly here at Y. So that is one pair of congruent angles that we have. Notice if you look at this slanted side here on from T to X on that original triangle, you have a triple tick mark. There's this point U in the way, and then there's a single tick mark. So think of that as if it was a total of 4 tick marks on that one side, and then compare that with the corresponding side on the other triangle. Notice again you have a triple tick mark, that point U is in the way, and then there's a 4th tick mark. And so you have the same total number of tick marks because we're comparing the same corresponding and congruent parts. So this is really a total of 4 tick marks from T to X, and this is also, you could think of that as 4. Now we're not literally counting up tick marks and saying, hey, 3 tick marks plus 1 tick mark is 4. I'm just kind of merging them together because I took out point U. When we recreated the diagrams, we just don't have that anymore. That point U doesn't exist. And then if we take a look at the bottom here, the bottom of this triangle, we have this side ZX. We have a double tick mark. There's a point Y in the way, which is now gone in my new diagram. And then there's this shared space. This is an overlapping part where the two triangles overlap. That's why we pulled the triangles apart. If you take a look at the right hand triangle, you see on its bottom side we have this segment YW. So from W we see this double tick mark, there's this shared space, and then we have this Y. So this is where the reflexive pattern comes in. And we would put a tick mark here, but we already have a single tick mark represented. We already have a double, we already have a triple, so I guess I'm up to 4 tick marks on my original diagram. So that means when we're marking the base of my redrawn triangle, we have 2 tick marks, then the point y is gone, and then 4, so 2 and 4 would mean I've got 6. Really the point here is that we have different numbers of tick marks on these two sides, so we know these two sides are not congruent. This is not an isosceles triangle. Here on the base of the right-handed triangle from y to w, same idea. You've got 4 tick marks, the point x is gone, you've got 2 more, so think of that as if it were 6. So what you can see now is these two are a pair of corresponding sides on the slanted sides. On the bottom, these two are a pair of corresponding sides, and we have a pair of corresponding angles that are congruent. So we do have 2 sides. Here's a side, here's a side, here's an angle, and we ask ourselves, is the angle between the 2 marked sides, side, angle, side, is the pattern? So the answer is yes. Notice that would be pretty hard to spot in the original diagram because of the overlapping triangles and all those tick marks floating around. So that's why this technique that we saw here in these 2 examples can really be useful to pull the triangles apart and mark up what you know. Can you tell whether these triangles are congruent? Well, we have to draw the diagram and mark it up. Don't try and do this in your head. It's too easy to get that information confused. So we need to draw triangle JRM congruent with triangle XYZ. That is, we'll draw them so they have corresponding parts. So here's the first triangle, JRM. Here's the second triangle, XYZ. So XYZ. So I'm just setting them up so that we have corresponding parts in the right location. So J is located first, that pairs up with X, that's located first, so J and X are in corresponding locations. R and Y are listed second, so they're drawn here in corresponding locations. M and Z are listed third, so they are drawn here in corresponding locations. Then mark up what they tell you. Let's say we know that JM is congruent with XZ. Let's say we know angle M is congruent with angle Y. Those are not corresponding angles. That's interesting. Let's say we know angle J is congruent with angle X. Can we tell if these triangles are congruent? Did you say no? The answer is no. Notice in this triangle on the left you have an angle-side angle pattern, 2 angles with a side between, and here you have an angle-side pattern, but it's not the same as the original. Here we have an included side, right? This side is touching both of the angles. On the second triangle, this is the included side because it's touching both angles, but that side is not marked. Some other side is marked. It's really these 2 angles that are causing all the trouble because these angles are told to us as being congruent, but they're not in corresponding locations. Remember, they have to be corresponding and congruent. Both qualities have to exist. So the answer is no, we cannot tell. We cannot say these triangles are congruent. Part B. Again, draw yourselves those triangles. Triangle JRM, triangle XYZ, and then let's mark up the parts. We are told JM is congruent with XZ. We are told segment JR is congruent with segment YZ. Right there. That's the problem. Do you see how that these are told to be congruent, but these are not corresponding parts. It should have been JR with XY. That's what we needed. Anyway, the third part is told as angle J with angle X. Those are corresponding and congruent. Notice on the triangle on the left you have a side angle side pattern, and on the right you don't have that. You have an angle side side pattern. That's none of the patterns we've learned. They're different. So once again the answer is no. We cannot show the triangles are congruent. Let's try part C. Again, draw yourselves the two triangles, so we can mark them up. Triangle JRM and triangle XYZ. Let's see what we have. Segment RM congruent with YZ. Angle M congruent with angle Z. Notice so far that these parts are not only congruent, but they're also corresponding. They're in the same relative position. Lastly, angle J congruent with angle X. So they are in the corresponding locations, and here we have an angle, angle, and the side is not between the two marked angles. So the answer is yes, we can show that triangles are congruent. The reason is it's the angle, angle, side pattern. Here's the fourth one in the series. Again, here's our triangles, JRM and XYZ. Let's mark up what we have. We're told segment JR is congruent with segment YZ. There it is. That's the mistake right there. They may be congruent, but they're not in corresponding locations. So already I'm thinking this answer is going to be no. But let's continue on. Segment RM, give that a double tick mark, pair it up with ZX. Again, we have a pair of sides that are not corresponding. And lastly, MJ with XY. Once again, we don't have those corresponding locations. So they may be congruent, but they're not corresponding. So the answer is no. We cannot show the triangles to be congruent. All right, let's take a look at this last diagram here. Example 5, state the third congruence that is needed to prove that the two triangles are congruent. So once again, what they're doing is they're giving us some information, and they want us to use a particular pattern. Because we're using 3 examples on the same diagram, it gets really messy with all the markings on it. So I'm just going to redraw that diagram here for this first one. So this is triangle DEF. So there's DEF. This is triangle QRT. QRT. And I'll just mark up this one instead of the original. Alright, so what we know is that D is congruent with Q, and F with T. So we always have to have 3 congruent parts to show the triangles are congruent. They're asking us to use this particular pattern of the angle, angle, side. Well, I already have 2 angles marked, so what's missing is a side. Which side? Not this one. That's between the 2 angles. We don't want a side between the 2 angles. We want a side that is not between the 2 angles. We actually have 2 choices. We could choose the right-hand side, or we could choose the left-hand side, because they are sides that are not between the 2 angles. So we have 2 correct choices. If I pick the right-handed side, it would be segment ET with segment RT. But just so you know, it could have been the left-handed side as well. For the second part, I'll use the original diagram here. Let's say we know that angle E is congruent with angle R, and segment EF is congruent with segment RT. Okay, we need to find 1 more pair of parts to make this pattern work. We're looking specifically for the angle side angle pattern. That means we need 2 marked angles, and I only have 1 marked angle. So the question is, if I'm trying to identify a pair of marked angles, should it be here at D and Q, or should it be here at F and T? Remember, we want the side to be an included side. It has to be between the 2 marked angles. So if I position my angle here, this is the included side, and that's not the one that's marked. So these angles don't work. We want angles F and T, because if we selected these angles, then the marked side is the included side. It is between the 2 marked angles, so it must be angles F and T. Alright, and then to finish it off, once more I'm going to redraw the diagram here so I can put new markings on it. So here is my triangle DEF, and here's my triangle QRT. So here in this case we are told that angle D is congruent to angle Q. We're told segment DE is congruent with segment QR. We need one more pair of parts to show that we have a side angle side pattern. So I'm counting two S's, but I only have one side. So that means we need another pair of sides. The question is, where should we place it? Should we place it here on the right hand side, or should we pick the second pair of sides here on the bottom side? Well, we have to make sure that the angle is between the two marked sides. So that means if I were to select the right-handed side, the included angle would be located at E and R, but that's not marked, so that would be the wrong selection of sides. If I select the bottom sides as my third pair of congruent parts, then the marked angles are between the two sides. So we want these two sides. We want segment DF and segment QT. So in our notes today, we're focusing mainly on just identifying the patterns in the markings. We'll be doing more with proofs of these later. All right, so that should do it for our notes today.